Hello friends, in displacement measurement, today we will see about RVDT, rotary variable differential transformer. So first thing, what is RVDT? It is one kind of electromechanical transducer used to give the linear output which is proportional to the input angular displacement. The main function of RVDT is to detect the angular displacement and convert it into an electrical signal. Both the RVDT and LVDT workings are similar, but LVDT employs the flexible ion core for displacement measurement, whereas in RVDT employs a calm type core. This core will turn along the two windings of the transformer using the shaft. Now let us see the construction of RVDT. RVDT transducer has two windings similar to a normal transformer, such as the primary winding and two secondary windings shown in the following RVDT diagram. As we can see in the diagram, there is a one primary winding and two secondary winding. The AC voltage source is connected with the primary winding, and a calm type core, or we can say calm type core, is connected with the shaft. There is two secondary winding and there is a differential connection between that secondary winding. So the output of secondary E0 is equal to ES1 minus ES2, whereas ES1 is the output of secondary winding 1 and ES2 is the output of secondary winding 2. The two winding of the transformer wounded where the two secondary windings have equivalent number of windings. These are located on both sides of the primary winding of the transformer. A cam formed a magnetic core which is made with a soft iron is coupled to a shaft. Thus, this core can be twisted among the windings. The construction of both the RVDT and LVDT are similar, but the main difference is the shape of the core in transformer winding. This core will turn between the two windings of the transformer due to the shaft. Now let us see working of RVDT. The typical RVDTs are linear over a plus 40 or minus 40 degrees. Sensitivity is about 2 millivolt to 3 millivolt per degree of rotation, and the input voltage range is 3 volt RMS at frequency ranges from 400 Hz to 20 kHz. Based on the movement of the shaft in the transformer, the three conditions will be produced, such as when the core is at null position, when the core rotate in clockwise direction, when the core rotate in anti-clockwise direction. So let us see the case number 1, when the core is at null position. In the first condition, when the shaft is placed at the null position, then the induced EMF in the secondary windings are similar, although reverse in phase. Thus, the differential output potential will be 0 and the condition will be E1 is equal to E2. So here E1 is equal to E2 and there is a differential connection between two secondary winding. So as we all know, E0 is equal to E1 minus E2, and here E1 is equal to E2, so E0 is equal to 0. Now in case number 2, when the core rotate in clockwise direction. In the second condition, when the shaft rotate in the direction of clockwise, more section of the core will be enter across the secondary winding 1. Therefore, the induced EMF across the secondary winding 1 is higher than the secondary winding 2. Hence, the differential output potential is positive and the condition will be E1 greater than E2. So, E0 is equal to E1 minus E2. Here, E1 is greater than E2. So, we can say that E0 is positive. Now, in case number 3, when the core rotate in anti-clockwise direction. In the third condition, when the shaft rotate in the direction of anti-clockwise, more section of the core will be entered across the secondary winding 2. Thus, the induced EMF across the secondary coil 2 is higher than the secondary coil 1. Hence, the differential output potential is negative. That means 180-degree phase shift, and the condition will be E1 less than E2. So E0 is equal to E1 minus E2. Here E1 is less than E2. So we can say that E0 is equal to negative. Now let us see some of the advantages of RVDT. The consistency of RVDT is high. The exactness of RVDT is high. The lifespan is long. The performance is repeatable. The construction is compact and strong. Low cost, resolution is infinite. Linearity is excellent. A wide range of dimensions. Now let us see some of the disadvantages of RVDT. The output of RVDT is linear, about plus 40 or minus 40 degrees, so it restricts the usability. The contact among the measuring exterior as well as the nozzle is not possible for all time. Now let us see some of the application of RVDT. Actuator for controlling flight as well as engine, fuel valve as well as hydraulics, brake with a cable system, modern machine tools, a nose wheel steering system, weapon and torpedo systems, engine fuel control system, aircraft and avionics, engines bleed air system, and robotics. Thank you very much.